pleasant morning to our distinguished speakers and all of our participants in Zoom, Facebook, and in YouTube. We welcome you to the seventh episode of the Biological Research and Services Laboratories webinar series with the theme PaleoConnect, where the past is the window to the present and the future. I am Nikki, your MC for today. Before we begin, here are a few reminders we need to observe for today's webinar. Please turn off your microphone and video camera during the presentation of our speakers unless requested. Please note that the webinar is being recorded during its whole duration and is being streamed in Facebook and in YouTube. We would like to see and hear your comments and questions. The chat box is open to accommodate these and we'll be entertaining all of it during the open forum. We encourage everyone to stay and join in the photo documentation by the end of the webinar. And for those who will be needing a certificate, you need to accomplish the evaluation form. The link will be shared in the chat box by the end of the webinar as well. So a little introduction on who we are. BRSL, or the Biological Research and Services Laboratory, is one of the four research and technical laboratories of the Natural Sciences Research Institute in the University of the Philippines, Diliman. We aim to be a leading laboratory in biological research and technical services in the Philippines by promoting and producing world-class research and technical services and performing and providing technical assistance and analytical services and protecting life and environment through international guidelines. We have different facilities for different laboratory works. There is the Cell and Tissue Culture Laboratory, DNA Laboratory, General Equipment Laboratory, Microbiology Laboratory, and Microscope Room. Our focus research revolves around natural products, genotoxicity of environmental pollutants, bioarchaeology, food safety, sustainable and renewable energy, phycology, virology, molecular diagnostics, and biorisk assessment. We also conduct workshops in laboratory handling, basic and advanced molecular biology techniques, microalgae, and plant chromosome preparation. Other than webinars such as this one, we also do services in technical advising, online consultation, research assistance and internship, microscopy, bioassays, and equipment use. So that's who we are. And to help us begin this webinar episode, let us all welcome the esteemed director of the Natural Sciences Research Institute, Dr. Elmer S. Estacio. Sir Tooks.
Hello, good morning.
Good morning, sir.
Morning, hi, hello. Yeah, morning, everyone. I would like to primarily commend the Biological Research and Services Laboratory for consistently organizing this very interesting and, as it turns out for today, highly diverse BRSL webinar series of 2021. April has not even passed, but they are now on their seventh installment. This only goes to show how prolific the BRSL is under the supervision of Dr. Ranjali Vital and her competent staff. Thank you very much. So it is not surprising that these webinar series are always well subscribed. I counted around 51 just before we started. I'm sure it's going to go up even more in a while. The breadth of the topics that the BRSL offers is impressive. Today, our two invited speakers who will be talking about the branch of scientific research that takes pride in data that become more relevant if they date further back in the past. Paleontology indeed uses the past as a window to understanding the present and the future. Appropriately titled webinar for today, if you ask me. In this webinar, we welcome Mr. Merrick U. Tublizo to talk about vertebrate paleontology in the Philippines, and the AVP, Dr. Elisa M. Peleo Alampay, to introduce us to the study of fossils in the Philippine setting. So with that, I would like to formally welcome all the participants. Let us all sit back and learn from our two invited speakers. Magandang umaga po sa inyong lahat. Thank you very much.
Thank you very much, Sir Tooks, for sparing time welcoming our audience and our speakers, and of
Pleasure.
course, joining us in today's activity.
A pleasure. Good morning.
Good morning, po. Okay, so, well, fossils are an important tool for understanding what life could have been and how it evolved in our planet. Although a thing of the past, these can actually give us a better understanding of the present as well as clues on where we are heading in the future. If you're doubtful about it, maybe our speakers for today can sway you. Our first speaker is an instructor 3 in the National Institute of Geological Sciences or NIGS here in UP Diliman, teaching geological courses including principles of geology and earth history. He used to work as an assistant in NIGS UPGAA Museum under Dr. Alisa Alampay, one of our speakers as well today, and in NanoWorks Laboratory under Dr. Alan Hill Fernando. He was a consistent university and college scholar when he was taking his bachelor's degree in geology in the same university. That is why he finished as cum laude last July 2020. He has been involved in different conference proceedings where he has presented his contributions in the geological and fossil studies in Naga City, in San Fernando, Cebu, as well as in the Visayan Basin. He was also the recipient of the 2020 Leticia Shahani Best Undergraduate Research Paper in Geology for his study on revisiting the geology of South Central Cebu, new insights on the evolution and development of the Visayan Basin. To give way on vertebrate paleontology, its current status and future prospects in the Philippines, I open the virtual floor to Mr. Mary Q. Tablizo. Sir?
Thanks, Miss Nikki, for the introduction. So um share my screen. Sorry, I stopped your screen share. So I'll share my screen first. So can everyone see my screen right now?
Yes, we can see it.
Yeah, okay. So thank you, ma'am. So let me start again. Again, I'm Mary Tabiso, currently an MS Geology student and instructor at UP NIGS, and I'm currently at my first year. So for today, I'm going to talk about the vertebrate paleontology in the Philippines, its current status. We're going to look at the history and what the localities, as well as the future prospect of the field um, here in the Philippines. So please be guided with this outline. Sorry. So I'll begin with again the introduction of the field and its history and status here in the Philippines, the localities and general stratigraphy, basically how we can plot them through time. And in terms of the future prospects, I'm going to highlight the fossil gap, the possible research teams that can be explored, new localities that we can further explore, as well as on your side, what you can do. And if you want to teach the field on your students, what you can explore. So I'll begin. So as you can see here are images of fossils. So these are the fairly charismatic ones that most of you would typically link to what paleontology is. So the first two are actually dinosaurs, a T-Rex and a Triceratops. So obviously they're very famous, a very charismatic group of large reptiles that existed during the Mesozoic and then are now extinct for the most part because well birds are still dinosaurs. And another example would be this tooth of a megalodon, which is a shark, a very large shark, as well as these Dunkleosteus. So for those who are um, in my generation, I guess, so there was a game called Hungry Shark. So these two are actually in there. So the Megalodon and Dunkleosteus. So if you played that game, you might have reached that level wherein you can use the Dunkleosteus or the Megalodon. And lastly is this an image of mammoth. So this sample is from a Mammuthus columbi. But if you've watched the Ice Age series, Manny is actually a woolly mammoth. So the same genus, but yeah, they're fairly charismatic. So these are different organisms that are generally the scope of the field of vertebrate paleontology. So what is vertebrate paleontology in the first place? So vertebrate paleontology is a subset or a subfield of paleontology that specifically deals with vertebrate organisms. So vertebrates are those that have backbones, that includes fishes or us mammals, um, reptiles, and amphibians. So all of those organisms are, well, generally the focus or the scope of the field of vertebrate paleontology. And if you may ask, why in the first place do I want to study vertebrate paleontology? So ever since I was a kid, I'm actually a fan, a very big fan of dinosaurs. So I sort of nerdy about those. And as I go through my primary education, secondary education, I later on learned that there was a field called paleontology, particularly vertebrate paleontology, that focuses on or studies generally these organisms that are really died, just prehistoric megafauna, if you may. So that's why I enrolled in the BS Geology program at UPNIX, and luckily I was able to graduate last year and now starting my MS Geology program, focusing on vertebrate paleontology. So I guess that's that. So continuing on, what is the first thing that will come to mind aside from these fossils that are already in display in museums? Or this. So if you watched or if you've seen a news articles or that, you can expect to see these very big sites, and they have this very big bones. So these are, well, very rare, if you may, but for the most part, in vertebrate paleontology, this will involve a collection of very small fragments, and that's still vertebrate paleontology because it's really rare to find these articulated and large pieces preserved because the fossil record is not will not really preserve that much. Okay, but personally haven't been in a big site that is particularly focused in vertebrate fossil digs. So I'm looking forward to that, and yeah, I hope we can do some field work very soon. Um, so after this, I'm going to proceed with the fossil localities. Just want to clarify that I'll focus more on the megafauna that have been collected so far. And I acknowledge that there were several microvertebrates, or those that were actually subfossils, a bit younger, that were described or published, particularly in Cagayan Valley as well as in Palawan. So I won't be discussing or including those materials in my presentation today. So again, we can now proceed. So let's begin from north. So one very prolific fossil locality is actually in Cagayan. So we have several megafaunal taxa that were collected in Cagayan. So here, shown in this particular site, are two proboscideans. So these are the group of mammals, includes the elephants, the mammoths, and stegodons. So for our case, we only have stegodons and elephants and stegodons. So as you can see here, a list of these species that were described in the literature. So for stegodons, we have Stegodon trigonocephalus, which is a taxa that is first described in the Indonesian islands, as well as our own endemic dwarf stegodon, Stegodon luzonensis. So these were typically associated with tectonic deposits. That's why they are typically pegged at around 700,000 years in age. So um, the Stegodon luzonensis is fairly small, considered to be a dwarf form, but a bit larger than those that were found in the south, in Celebes and in Timor, for example. And the next group are the Speleoloxodon elephas and elephas, noted to belong to the Elephas namadicus group, and a possible Elephas maximus. So these are the ones that are related to the elephants as we know them today. And we have actually some large forms that were collected in Cagayan. So so far, and in this image, you can see here the molar of Stegodon luzonensis. Although the first one that was described was actually from Luzon, the material is actually not available based on the review of uh, DeVos and Bautista 2002. So they noted that a new specimen for a type specimen rather for Stegodon luzonensis that was collected in Solana, Cagayan. Other taxa that were collected in Cagayan include the newly identified, described Celebocerus cagayanensis by Engico et al. 2016. This actually a pig or boar, as you can see in this paleo art. And here are its molars that were lifted from the publication of Engico et al. Also, we have this endemic rhinoceros called the Rhinoceros philippinensis with this molar, and we actually by in Gito as well, a new site wherein they were able to collect a semi-complete butchered rhinoceros, which is actually almost still articulated. So a very, very important find to define this taxa. Additional fossils that were collected in Cagayan Valley include a giant tortoise, crocodile teeth, the cervids, and the bovids. So I'm not going to go through them one by one. So going south, we can now proceed to um, Pangasinan. So in Pangasinan, were actually several fossils were also collected, and they are actually collected in situ. So they have a better stratigraphic restriction or positioning, wherein several expeditions were done. So a pygmy elephant was initially recovered in 1911. Tapos it was then stored and then later on rediscovered by Bayer in 1935. And then von Koenigswald identified the fossil to be Elephas bayeri, which is another endemic but a pygmy Elephas species. However, that particular specimen is actually missing and or not based on the view of Bautista and DeVos and Bautista 2002. Further comments noted by von Koenigswald is that this Elephas, take note guys, the images I used here are not actually the paleo arts that were for those specific taxa because I was not able to find them, but these are of the same genus. So we can probably guess on how they would have looked like in a way, but again, the proportions might have been different. So going back, they noted that Elephas bayeri it actually originated or evolved from the more widespread Elephas namadicus that can be found throughout Southeast Asia at the very least. However, those that were in collection at the National Museum includes only this large Elephas molar, which is again not the one that is described or described here in Elephas bayeri. So it might be of a different species. Additionally, Stegodon molars are also collected in Cabardrian Island. So as you can see here in this specimen, but in De Ocampo in 1983. Additional specimens that were collected also includes Rhinoceros philippinensis and Cervus sp and Bubalus. And in terms of those that were ocean dwelling or marine, Yerstein and Walton were actually able to collect these black marine fossils. It's the Ompax indica, previously Macaira indica. So as you can see here, we have the throat as well as the pectoral fins, and it's neoprene. So it was dated to be from the early Pleistocene, which is around um, 2.58 to 700,000 years ago. And then now in Metro Manila and Rizal and its environs, we actually have several finds here as well. So, for example, we have also described in the literature, there was also described Stegodon trigonocephalus as well as Stegodon luzonensis. Again, the original material or the type specimen, the holotype for Stegodon luzonensis was actually from a surface find in Rizal. However, the original specimen is the storage area of that original specimen is currently unknown. So in a paper published by Scholl et al. In a team that includes Dr. Elisa, they were able to collect these specimens that are currently stored at the MIGS UPJA Geology Museum. We have here several molars as well as several tusks that belongs to a stegodon species. The specific species still not identified or in the paper. So further studies might be warranted for this. Additional taxa that were recorded in this area includes elephas as well as a rhinoceros philippinensis. And aside from those, they were also collected by a team that includes Dr. Elisa was this giant land tortoise. So initially described to be Manuria sondari, but with the revision was considered, and then later on it was renamed to Megalokelly sondari. So it's actually a giant large tortoise. So for you to have an idea of how large it is, so the carapace is estimated to be around 90 centimeters, so almost a meter, so fairly large. And currently we don't have these large tortoises anymore. So we have here a femur material, the coracoid, and the acromia. And also in Tres Hermanas, in the several freshwater sardines were also collected. So these were actually noted to look the same or have a similarity with the Sardinella tawilis that are endemic in Taal. So we might have some relation to that. And yeah, so we have here several fossils that were found in the Lacustrine deposits in Laguna Formation, of Laguna Formation. And then further south is actually, so far, the oldest fossil collected here. I mean, it's not collected, it was discovered here in the Philippines. So it was the Serenia fossil that were discovered in the Puerto Princesa underground river. So along the cave falls were embedded protruding this still articulated, mostly rib cage material of a Sirenia or those well, in the same family of dugongs and manatees, possibly a dugong, during the early Miocene, so roughly 20 million years ago. So um, these were noted to be a bit smaller than the dugong dugon, like this one, which we have at the present. So it's fairly smaller. But this was not collected or extracted from the cave walls because the authors of the paper suggest to preserve the natural beauty of the cave. So possibly future technology we can scan it and further investigate and possibly identify what specific or describe what specific species that this might be, which can further in the study of the diversification and possibly the migration of the Sirenians can elucidate some ideas. So I just want to take note that a lot of fossil vertebrates were collected throughout Palawan, particularly dating to the latest Pleistocene to early Holocene, including those that were published by Ochoa and Piper in 2017 and Piper et al. In 2011, as well as those that are dated to be from the late Quaternary, from Rice and Garong 2001, Ochoa et al. And 2014. So these assemblages includes deers, pigs, cats, or even some tigers were noted, macaques, and others that were currently represented by the modern fauna that we can see in Palawan that are relatively associated with the fauna in Borneo. So we have some relation in Palawan and Borneo, which is believed to be the only island of the Philippines that were connected or have some sort of connection with the larger land masses throughout Southeast Asia, while the other parts of the Philippines were believed to have remained isolated, even with the lowering of sea levels during the last glacial maximum. So continuing on with terrestrial fossils, we can now proceed in Anay. So as you can see here, currently in display at the National Museum Western Visayas. So we have two specimens. One is from a juvenile stegodon and it's smaller, and another is from a relatively large elephas, as you can see here. So these two were collected in Cabatuan, Iloilo province, and uh, might possibly uh, have some if further study might be warranted, like to compare it with other taxes that were collected in for example in Luzon as well as and the other one in Metro I will discuss in Mindanao. So continuing on within Visayas is a new publication, relatively new publication from Croft et al., wherein the new endemic species Bubalu cebuensis was described. So it was noted to be fairly young, so roughly in the towards the latest Pleistocene, towards the Holocene, which is the current um, period time, and um, generally this fossil was described to be fairly smaller than the Tamarau that we can find in um, Mindoro. So this is the Tamarao in Mindoro, and this is the reconstruction of the Bubalu cebuensis, or locally called as the Cebu Tamarao. So it's about 25% smaller than the Tamarao that is currently living in, well, I mean, in existence. So we have here the metatarsal, the vertebra, and the molars. And then lastly is actually the oldest find here in the Philippines. So these were actually first collected in, I mean, at least described in 1887, and then later on named by, or I mean, described by Norman to be a new species called the Stegodon mindanensis. And several researchers actually looked at this specimen, which are actually talismans that were stored in ethnographical collections in Dresden, Germany. So its taxonomic position is really uncertain because the first one to describe it uh, noted it to be a stegodon, and then Janesh in 1911 noted or described it to be an elephas, which is a different genera or genus, and then Matsumoto in 1924 described it to be a parastegodon, and then in Osborne 1942 it described the specimen to be of Archidiscodon. So um, we the fossil is not in the Philippines right now, so we cannot really do further studies unless we collaborate with the museum in Desden. And this actually might be a very important um, fossil to look at. Another fossil was actually collected in Mindanao, and von Koenigswald actually described that to be another Stegodon mindanensis. However, that's still uncertain because they were not able to look at the holotype that was described by Naumann. So this in the article of De Vos and Bautista, it was described to have been collected in Northwest Mindanao. However, if we're going to look at the monograph of Osborne 1942, these specimens were noted to be from Northwest Mindanao. So um, I guess it needs further study to at least have some sort of to clarify its taxonomic position. So basically, the next one is sort of the summary. So as you can see here are different taxa that was described in the different areas or fossil localities. So this one, yeah, Weeden mesofauna is actually the term itself is actually already used in previous studies. So this is composed of an elephas, a stegodon, a rhinoceros philippinensis, the Celebocuerus cagayanensis, a giant land tortoise, a bubalus, and a cervus. So these three actually are not yet taxonomically refined. And the next one is in Bolinao. It just coined the term because the area is in Bolinao, but this term hasn't been used in any previous studies. So this is the ones that have more proper stratigraphic documentation. So um, further study regarding the tax already can be done. So it is actually composed of an elephas. Also, I should have included here another image of an elephas because again, elephas bayeri was described here, which is a dwarf elephant or a dwarf elephas. We also have the stegodon and a bubalus and cervus. And in Metro Manila and Rizal, we have this, I coined the term again, Guadalupe fauna, which is composed of Stegodon luzonensis, and Elephas, Rhinoceros philippinensis, the Megalokelly sondari, an antelope, a bubalus, and another cervus. In Panay, we have so far, based on those that are published, only the Elephas and Stegodon. And in Cebu, we actually have this Bubalus cebuensis. And then lastly, in Mindanao, we have Stegodon mindanensis. So basically, that's the summary so far of the Pleistocene fossils that were collected in the Philippines. So continuing on, let's proceed with the stratigraphy. So if we're going to plot them through time, geologic times, you can see most of our fossils that were collected from vertebrate fossils were actually restricted to the Pleistocene, relatively young in age, and these are some of the ranges that are in publication, so might not really be accurate. I mean, it's based on single specimen, so that might just be the only the range. But as you can see here, the only ones that deviates from this clustering of fossils are actually these marine or aquatic um, early Miocene Sirenia fossil. So this we can now proceed with the future prospects. So we have this very large gap wherein we don't have any vertebrate fossils that were collected, and also here, although this is a bit more, I mean, we're less likely to collect any fossil here because of the rocks that were dominant in this particular time period, which now leads us to the geologic map. So, just want to highlight for you guys to take note is that throughout the most of the geologic history of the Philippines actually was submerged. And we have several islands probably that were already exposed since the Eocene to late Oligocene. So in Luzon, for example, and the Visayas, Catanduanes, and Surigao. So those areas must have been exposed early on, but the rest of the Philippines remained submerged. And so we have an abundance of marine sedimentary deposits. However, take note that even though it's in a marine setting, we can still find vertebrate fossils, as exemplified by the discovery of the Sirenia, or the antique dugong fossil, from Palawan. So we have this entire country for wherein we can probably look for these marine fossils. So, considering the research teams, what can we possibly further study? If we're just going to consider what we currently have, we can probably look at the funnel assemblages. We can probably compare the different funnel assemblages in between the different areas. Is there a variation, which can lead us to have an idea of the paleoecology, as well as the how the migration patterns work. So as you can see here, the main hypothesis regarding the migration of these large mammalian fauna is north or southwards. So from Formosa or Taiwan downwards towards the Indonesian islands. And we have also this continental route, which only reached Palawan because it was noted to need a land connection. So again, as I've mentioned before, most of the Philippines remained isolated from any land masses. I mean, not connected, not no land bridges were deduced based on the depths if we're going to just directly lower the sea level. So only Palawan might have some sort of connection with Borneo, while the rest might have been completely isolated. So we have this very good site of where we can have evolution and study evolution, the insular dwarfism that can be seen in most of the proboscideans. So that's one theme that can be explored, as well as in a very prevalent theme right now is about the extinction of these uh, large mammalian fauna in relation with the arrival of hominins. So we actually have very prolific archaeological studies regarding this, and uh, there. So I can probably say that these are at least as for my case, that I'm very particularly interested in to study. So continuing on with the new fossil localities, again, I'm going to discuss two. So the first one is actually in Palawan as well. So in the limestone caves, there is actually these set of fossils that are embedded within a cave in a tower karst. So these were initially identified, preliminarily identified to be that of cetaceans. So cetaceans are those a group of mammals, well, seagoing mammals that includes the whales, the dolphins, porpoises. So this were preliminarily identified to be cetacean, but it still needs to be extracted to be further studied. So uh, we need to go to Palawan to collect for these materials so that we can study it further. So uh, stay put, guys. So about this, and then another site is in La Union. So here in a recent field by Dr. Alan Fernando, which is who is currently my advisor. They were able to collect these several specimens. It includes that of a servus, bubalus, and crocodilo. So the area is actually a paleochannel deposit that, as you can see here, cuts across the Baknatan limestone. So that's in La Union, and that's actually for the fossil locality. So I just want to share some websites for those who are actually teaching, well, at least earth sciences or geology, or you personally. If you want to explore, we have, not us, but there's an available website, the Paleobiology database. So here, aside from the date being a database itself, you can actually explore the different fossil localities so far that are in publication. So you just need to input here the taxa that you want to look at, probably also the time. So for time, you can just click here respective time periods that you want to explore, and then the paleogeographic reconstruction or models will be noted here as well. So there is actually very powerful tool. So if you want to study or just explore the fossil record, so you can actually go to this website. And another one is about this ancient Earth globe. So likewise, just shows the paleogeographic models from Scotties. So you can input here your area and probably look. I mean, based on the model, look on where it was positioned at that particular time. And also, you have here a specialized or a dedicated segment wherein you can jump to the periods wherein this important biological events happen. So lastly, I just want to share to you these institutions that you can probably follow if you want more updates regarding paleontology, vertebrate paleontology. So we have here the Paleontological Society of the Philippines, the National Museum of the Philippines, Science and Geosciences Bureau, and at the University of the Philippines, the dedicated institutions include the National Institute of Geological Sciences and our laboratory, NORS laboratory, and we also have a museum at UP NIGS, the UP National Institute of Geological Sciences Museum. You can follow that on Facebook, as well as the Archaeological Studies program. So that ends my presentation. So here are my references. Thank you very much for listening and allowing me to share some insights and some ideas and vertebrate data. So thank you very much for listening, everyone.
All right. Thank you very much, Sir Tabliso, for sharing your knowledge and, of course, for that very insightful lecture on the existing and, might I say, diverse vertebrate paleontology in the Philippines. Okay, so I know some of you guys already have some questions for Sir Tabliso. So please feel free to drop in your questions in the chat box. Just include your name and your affiliation, of course, your question, and we'll be addressing those after our second speaker. So for our second speaker, she's a professor of geology at the National Institute of Geological Sciences as well, uh, here in UP Diliman, where she has been teaching undergraduate and graduate geology courses for more than 20 years. She also heads the NanoWorks Laboratory in the same university, doing research on fossils and to understand the Earth's geologic history while mentoring graduate students in their thesis research. She obtained her bachelor's degree and master's degree in the same university and her doctorate degree in earth science at the Scripps Institution of Oceanography, University of California, San Diego, US of A. Currently, she is also the Assistant Vice President for Academic Affairs, in charge, among others, of the quality assurance initiatives of the 8 constituent universities of the University of the Philippines system, all over the country, of course. In 2006, she spearheaded the creation of MIG's UPGAA Geology Museum in UP Diliman, which showcases earth science exhibits and interactive displays, which complements the teaching and public service mandates of the university, and it has been visited by students of all ages. She was a Balik Scientist Awardee of the Department of Science and Technology and was awarded as one of the nation's outstanding women in nation service or towns in 2007 and PRC Outstanding Professional of the Year in Geology in 2020. Here to present a discussion on the fossils in the Philippines, understanding the past and the present, let us all welcome and put our hands together for Dr. Alisa Pileo Alamtay. Doc?
Thank you very much, Nikki. Good morning to everybody. Thank you very much to the BRSL Lab and to NSRI for inviting me to be part of this webinar series. Thank you to the director, Dr. Elmer Estacio, and to the lab head, Dr. Pierre Angeli Vital for inviting me. And thank you everyone for being here. So let me start sharing my screen. Can you all see the screen right now? I have quite a number of slides. Don't be scared. I'm going to go through them very, very quickly.
Yes.
So I hope you can see them already.
Yes, Doc.
Thank you. Thank you. So I designed the talk so that it's both comprehensive, but at the same time, I toned it down a bit. There are some papers here that were mentioned, but I'm just going to skim through them because I know that we have participants who are probably not as interested in a lot of the data, but just want to know, what is there in terms of paleontology here in the Philippines. No? So I'll just go through all of them. Okay. What are fossils? Firstly, I know many of the audience are probably biologists or interested or enthusiasts, paleontology enthusiasts. They're really just remains or traces of organisms that have been buried in the Earth's crusts for a long period of time. So we always qualify all of the phrases here because it's very important for us to understand what we consider as fossils. And you have to excuse me, my point of view is actually from geology. And so sometimes we tend to forget that, there were biological meanings to a lot of the words that we use. But we call ourselves sometimes a pseudobiologists because really our training has been in geology. No? So when you say remains or traces, it really refers to either their body fossils or trace fossils or what we call as ichnofossils. No? So body fossils are really, they really come from the organism itself, whether plant, animal, or protist or moneran. And the trace fossils are any trace that they leave in the sediments or in the rocks. No? So it's not the body itself. There are no bones, there are no parts that are left there. It's really just their behavior. So you see tracks, trails, borings of these organisms. And then we also differentiate fossils and artifacts. Fossils really are the natural remains of organisms, once living organisms, whereas, artifacts are usually human-made, human-made things. And we usually, as paleontologists, don't deal with that, with those kinds of remains. No? And then fossils come in generally at two different kinds, the ones that are unaltered, which means they have not been changed, almost not changed at all. For example, the woolly mammoths of Siberia, which were buried not in the crust itself, it's an exception, it was buried in ice. And so for 25,000 years, it was buried in that ice, like frozen, as if, it's meat in the refrigerator or the freezer, and stayed there. And when they were found, the meat was still pinkish, and so they really remained unaltered, and even the hair of the mammoths were intact. But most fossils are really altered. The ones that are unaltered, like about the Jurassic Park story of the insects that were preserved in amber. Except for those things, a lot of these fossils have actually been changed already. They've been altered, either replaced or filled in, or just imprints are left of them. No? So, and then we always discuss, how long is long, because a long period of time is really, very relative, very subjective. And so, as geologists, a million years is nothing. That's really very young. And usually when we teach fossils to beginning students, we say that, as long as it's about, more than 10,000 years old, I guess you can consider it as a fossil. But of course, that's not a hard and fast rule. It's just, just so the students can imagine, how long is long. No? And actually 10,000 or so is around about the boundary between the Holocene, or the recent time, and the Pleistocene. No? So that's why we say that. But actually, there's no hard and fast rule, really. And so we're called paleontologists because we study fossils, and it actually includes all related topics about fossils. It's not just, the systematics, the taxonomy of them, but also really, more importantly for geologists, we try to deduce what the environment was, how these organisms lived. We look at the paleoecology of the area, and then also interpret the geologic history of the particular areas in which these fossils are found. So whether in the ocean or on land. No? So we consider paleontology as a branch of geology, mainly because these organisms, or once living organisms, are really part of the earth. But at the same time, we recognize that it's also a branch of biology. So really, it's an intersection between these two really big sciences. No? But geology tends to be more applied because we use, geologists in general use physics, chemistry as tools, math, and of course biology as tools in order to deduce the history of the earth. Um, Geologists usually do not deal with the human fossils because there's just quite a lot to deal with. There's about 4.6 billion years of history to be, well, let's just say 4 billion years, because that's when roughly fossils were found. There's just so much to study already. And so we usually leave the human fossils and its artifacts to paleoanthropologists or archaeologists. No? And so that's sort of the divide. However, that's also an artificial divide in our minds. We also, actually, some of the geologists help archaeologists, or also become archaeologists in the end, if they deal with very young material. Very young, as I said, is, a million, hundreds of thousands, tens of thousands is actually quite young. So why are fossils important? They're the most tangible records in rocks of life and environments of the Earth's past. Really, that's all that's left. No, you can exclude probably the gas bubbles in ice that help us deduce what the climate was during the recent ice ages. But actually, all we have really are the rocks, even on Earth or in the planets around us, and even the planets around us and the Earth that we live on are actually just rocks. Now, they just happen to be giant, huge rocks. Fossils for geologists are important for age dating. We can't all the time subject our samples to radiometric dating. Sometimes it's almost impossible. There's nothing to date in terms of the minerals that are needed for dating. And so really we have to rely on fossils for that. No? We also use it for paleoenvironment reconstruction in order to determine what the environment was during the time that the organism lived. We also use it for correlation. This is, it might look like an inane word, like a harmless word, but for us geologists, this is actually a very powerful tool that we use in geology that enables us to compare and match different lithologic units or rock units from place to place. No? So for example, you can match the rocks from the entire European continent, for example, and between Europe and North America, and deduce what happened to those continents in the past. We can also reconstruct oceans using fossils by looking at the similarities and matching them depending on where they were preserved in the rocks. No? And so that we call that correlation. Okay, and of course, fossils are part of the natural heritage of the Philippines, and so it's really quite worthwhile to study them. Now, where do we find fossils? Now, in general, you find them in sedimentary rocks. They don't exist in igneous or metamorphic rocks because, as you know from grade school earth science, that those are changed rocks. You've already changed them, and so it's igneous rocks. No, I mean metamorphic rocks. You've already changed them. Igneous rocks, they come from magma, which is molten, and so it's very hard preserve fossils in those because they came from the melt, from molten material, and so nothing will survive. No living organism will survive that and be preserved in those rocks. So you have to look for sedimentary rocks, which are formed from the deposition of particles, of earth particles, or they could have been precipitated from solution. No? So like limestones, for example, and cherts, which are siliceous. Fossils are not rare. To the contrary, many people think that you can't find fossils everywhere. Actually, if you live here in Metro Manila, there are quite a number of fossils. It's just that there may not be as nice as or as complete as you would want them to be, but still there are fossils around us. In Diliman, for example, there are a lot of fossil plants that are embedded in the adobe or the tuff that we stand on. No? So well-preserved or complete specimens are the ones that are rare. The ones that we find in the museums are placed there because they're really beautiful, they're complete, and there are not that many specimens that can represent that particular group. In the Philippines, most of the fossils that we find will be mostly marine, and that is because of the geologic history of the islands. We're quite young geologically, and so and we were submerged under the sea or under the ocean, whatever you want to call it, for a long period of time, except of course for the parts that are continental. We're part of Eurasia, like Palawan, Mindoro, parts of Panay, for example, and so on. No? So the land fossils, for example, that Merrick just discussed earlier are all quite young. And you've noticed in the chart that he showed, they're mostly in the Pleistocene, except for the cetacean fossil that was found. Most of them are quite young because we didn't have land that's exposed until quite recently. When I say recently, it wasn't just yesterday. I mean geologically recently, which means tens of thousands of years ago. Okay, the earliest fossil that we have is actually from the Carboniferous. It's called Giselia sp. This is roughly how it looks like. Actually, we don't have the specimen anymore. It was discovered by Easton and Melendres way back in 1959, and then also republished in 1963 in the American Association of Petroleum Geologists Bulletin. But it's the only recorded oldest fossil that we have. I got this picture from, I think it's a synonym of Giselia sp. It doesn't exist in a lot of the records, but they say that it has affinity with Caninia, so it might be a synonym. So this one is also a little bit strange. It was found as a clast, which means it was included in a much younger rock unit called the Punso conglomerate in San Jose Mindoro. But this particular genus of rugose corals died out in the Permian, so they're quite old. No? So it's from the middle or upper Carboniferous. And so, this is what it looked like. Well, more or less probably how it looked like. The specimen was lost, actually. So that's really sad. So where is paleontology in the Philippines today? There used to be more of us. My generation is actually diversified also. They went on to doing other things. Most of us are in the National Institute of Geological Sciences, where many of the geologists are trained. Of course, there are also other universities that offer geology, such as Adamson and Mapua, who are also training future geologists who might turn out to be, later on as paleontologists. Because we are the school, or we are the ones in the university, we deal with everything, anything that we can find. We're all very curious organisms in the institute, especially in the NanoWorks laboratory. So we deal with microfossils. In particular, a lot of the work is actually in microfossils, and I'll explain to you why. But we also have a lot of invertebrate and vertebrate fossils. However, we're not as prolific as we would want to be, because many of us, some of us are not specialists, and so we're happy to have students who would like to specialize in them, and then we collaborate with other laboratories around the world in order to help them. Dr. Alan Fernando in particular is very active in that these days, and also very active in supporting archaeological studies. No? The National Museum of the Philippines is also another area or a place or venue where paleontology is alive. We also have lab mates who ended up in the National Museum working on invertebrates mostly, but also in microfossils as part of their master's thesis. No, but the collection there is quite interesting also. So it's worthwhile also to go to the National Museum to see especially the new branch. No, and of course the Archaeological Studies program, which deals with mainly human fossils and artifacts. And I see a colleague here from the Mines and Geosciences Bureau from the Department of Natural Resources. And they study mostly microfossils, and we have a specialist there on mollusks, Dr. Aguilar. No, and the Department of Energy also, because of oil exploration, oil and gas exploration, microfossils are actually very much used there for age dating. Now, why do we study fossils, especially the microfossils? Because they're found in sedimentary rocks, which comprise 75% of the rocks on the surface of the Earth. And of course, as you know, the surface of the Earth is about 75% ocean. And most of that, actually below the ocean, I don't know if you know, there's seafloor or ocean floor. And that ocean floor is actually composed of sediments that have been deposited over millions of years. No? Those sediments, especially in the middle of the oceans, are actually composed of plankton. Believe it or not, it's not rocks that were eroded from nearby continents, because when you're in the middle of the oceans already, they're no longer continents. And so what you have there actually being deposited as sediments are actually uh, microfossils or microplankton. I'm not microplankton. Yeah. So that's why if you look at the map, this is a very simplified map of the composition of the sediments of the ocean floor, just the top sediments of the ocean floor. You'll see that most of it is these greenish parts. These comprise, all of the parts of the oceans that are either composed of calcareous or siliceous deposits made out of plankton. And to the point that they're so mushy that they're called oozes. And when you look at them in the microscope, it's really full of either foraminifera, which I will show later on, foraminifera, calcareous nanofossils, diatoms, or else radiolarians. So that's the reason why we geologists have to study or are very interested in studying the ocean, these microfossils, is because the ocean floor is made up of them, and later on they become rocks. No? Okay, so these are the top four groups of protists that many of us study because there is also some economic use in them for oil and gas exploration. So in the lab, the tradition has been coccolithophores and foraminifera. Many of us as young paleontologists studied foraminifera because you don't need a high-powered microscope for it. So that's where we spend a lot of time picking them out of the sediment, sieving them and picking them out of the sediment. So foraminifera are animal-like protists composed of calcium carbonate. And this is where we specialize in. No? So coccolithophores are also called calcareous nanofossils or calcareous nanoplankton. These are plant-like calcareous organisms. In the siliceous realm, there's the plant-like diatoms and the animal-like radiolarians. All of them have been studied so much that there is a standard scale that you can look at and that we continuously also contribute to improving. And that scale can tell you that, like when you find a particular fossil, you can determine the age of that particular rock or sediments that you're looking at. So just to introduce those, the two major ones that we study in the lab, foraminifera are about 100 microns to 20 centimeters in size. And coccolithophores are the spheres. When we say the spheres, it's the complete ones, as pictured here. They're about 5 to 100 microns. And the liths, the individual ones of these, that which are the ones that we really see in the sediments, are about 2 to 25 microns. So micropaleontological research, or the study of microfossils in the Philippines, really started from foraminifera because technology was limited. The microscopes were not as high-powered yet at the time, and mostly because of petroleum exploration. It was one of the first that was established, foraminiferal biostratigraphy, or using foraminifera in order to determine the ages of the rocks or the layers of rocks, started quite early. And then later on, when more powerful microscopes were invented and available in institutes and universities around the world, then coccolithophores came into play, especially when geologists, especially from Scripps, where I graduated from, started the ocean drilling program or the deep sea drilling project. No, so scientists, mainly geoscientists from around the world, would go on this ship for about 2 months. Dr. Fernando and I, for example, were able to go separately on these voyages. You stay on the ship for 2 months, not going on land, and 12 hours each day, you look at the microscope and identify calcareous nanofossils, which is quite fun, actually. It's really something to a very nice experience. We also have, of course, SEM, the SEM microscope, which is very much used, especially for taxonomy and identification of some of the smaller ones. I pictured here also BRP Gregorio Velasquez, for which one of the streets in the College of Science is named after. It used to be RV Melville, which was a Scripps ship, and which some of us have gone on during a Philippine-US expedition where we collected a lot of sediments. So coccolithophores are calcareous nanoplankton. They're quite small. They're protists. They belong to the marine haptophyte, chrysophyte algae group. They're quite small, as I said. They're made up of calcareous of calcium carbonate. They break up a lot, and so these pictures, which were taken, which are part of the atlas that we are currently in revision, is actually they break down. No, they break down. These liths break down from these cocospheres, and those are the ones that we see in the sediments. They've been around for some time, but really most useful from the Cretaceous to the present. So in the Philippines, coccolithophores have been studied from surface sediments, from core sediments, from land sections, from sediment trap samples, and from seawater samples. Just to show you some of these studies, this is a study that we did in Lingayen Gulf, Subic Bay, and the base of Marinduque. And we found that, we really have a low diversity nanofossil assemblage closer to the coastal areas, and Gepharocapsa oceanica, which is pictured here, is the most dominant species. Dr. Fernando also did his thesis from sediments that were collected across the South China Sea, so from the eastern to the western side. And so all of these samples showed, again, the dominance of three types of species: the Emiliania huxleyi, Gepharocapsa oceanica, and Florisphaera profunda, differing between the two sides. Oceanica is prevalent on the eastern side, whereas on the western side, it's huxleyi, mainly because of the presence of upwelling off of Vietnam, as opposed to the side of the Philippines where there was no strong upwelling that was going on. Sediment cores also are studied. This one is part of the thesis of Debs Tangunan, who's now in Spain doing her postdoc already. So showing differences in terms of abundances of calcareous nanofossils in this area of Sulusi, and differing in abundances because of upwelling and non-upwelling areas. As I said, we went on these IODP, we call them cruises, but they're actually expeditions. It's not like a cruise, like a vacation, but you stay on this ship, which it's like a drilling ship, an oil drilling ship, which has a big pipe that goes down into the depths of the oceans. It can go thousands of meters, kilometers under the sea or the ocean, and then it can drill kilometers of core also, and that is brought up on the surface of the ship, and we study them, layer by layer. Based on that, on the one that I went on, Expedition 349 in the South China Sea, a grad student of mine was actually able to do his master's thesis. He's now doing his PhD in Canada, and he refined the shipboard age dates that we had based on the calcareous nanofossil events. And so this was the shipboard, and this was his revision of it. Although, it might look the same, but the refinement is actually a very good contribution already to the science. We also look at land sections. For example, this one is in Samar, the Katbalogan Formation, using these different types of nanofossils. This is by Debs and others. And then this one is in Mindoro, and helping refine the stratigraphy there and contributing to the tectonic history story of the area. We also look at sediment traps. These are recently the ones that we collect from these types of collecting instruments are recently they recently died, or are sediments that are being collected in the water column. So they're not at the surface of the ocean floor yet. They're not at the ocean floor yet. They're on the way there. And so some geologists called sedimentologists study these types of particles in the ocean in order to sort of meet the gap between the living, what is living or what is on the surface being deposited on the surface of the ocean. So the plankton, if it's the biological part, and what is left on the surface of the seafloor, because we lose a lot of them. And so we'd like to see, what really is being sedimented or being deposited as they go down on the ocean floor. So we've been on some of on several of these cruises. In particular, I went to the South China Sea from Vietnam to the Philippines, and just around the South China Sea, collecting these sediments along with surface sediments. So basically, this is sort of a cartoon of what happens. So that collecting funnel is the sediments in that collecting funnel is what we get. And based on that, for example, looking at this area of the South China Sea, we see that during this is a record, and you leave that funnel there for a year, so or more. And so we see that during you see a seasonal record of the amount of the abundance of these calcareous nanofossils or coccolithophores that are being sedimented. This one, another area comparing two different collecting periods. It was a strong El Nino period, 1998. And so based on that, just looking at the colors here you'll see that during El Nino times, there was not much difference or diversity, but come La Nina times or non-El Nino times, you have more of the other coccolithophores getting into the assemblage. We've also studied, because of the many cruises and many collecting expeditions that happened from just from a bangka to a ship. We really had many opportunities also whenever we can to get seawater samples, and so we've also had friends. We've also asked friends, who are going out on cruises to collect water for us, and sometimes to filter water for us, and we're very grateful for that. And because of that, we've decided to put together this Atlas of Coccolithophores, and we hope that it will be published sometime soon. No? So I put in here the father of geology. He's James Hutton. He's the one who said that the present is the key to the past. So that's why I always say, we're like pseudo biologists, because we have to study the present, what is going on right now, so that we can deduce what's going on in the past. To show you some of the other fossils, and I've concentrated on the ones that the members of the lab have been part of. And so these are pictures from our studies, either from fieldwork for class or fieldwork for research or fieldwork for fun. No? So these are large foraminifera. These are the animal-like protists. This is a close-up picture I took recently. It's from a rock in Tanay. And then when Dr. De Silva looked at it and pictured it in the microscope, this is what it looks like. It's Nummulites. It's from the Eocene. No? So tens of millions of years old. No? And these are the smaller versions of these foraminifera. These ones are the planktonic ones. And this one, when you look at it in a petrographic microscope on the rock, or the rock microscope in a thin section, very, very thin sliver of the rock, you see this particular one, which is a planktonic form called Globotruncana, and it's an index of the Cretaceous. So we can determine the age right away of the rock just by looking at these fossils. In terms of invertebrate fossils, I'll go through them very fast. They're really mostly pictures. In Itbayat, Batanes, we took this picture of a coral, really nice coral formation there. In the Mortis, Dr. Fernando took these pictures. This is a really nice reef here. And as you can see here are branching corals preserved in, these are quite young sediments, no? Rocks. This one from Santo Domingo, Ilocos Sur, of more of these corals, and you can see a fungia there, a solitary coral. This is from a paper by presented by Doms Gubalia and Dr. Fernando. These are brachiopods, no? Which were collected by different people, from Dr. Matias, who is our predecessor, and also from other fieldworks that that they have been through. No? Uh, these are mollusk gastropods embedded in a sample, an outcrop in Itbayat in Batanes during a field work that I took. These are also other gastropods from an area in Magat Dam in Isabela. You might know Bulinaw, Pangasinan. In one of those areas, there's a so-called park, and these are fossil giant clams, not the living ones that we see in Silaki. These are the fossil bivalves that we took from a recon fieldwork in Alaminos. This is from the study of Clarence Magtoto, one of the graduates of the lab. His master's thesis was on this chemosynthetic area in Sison, Pangasinan. And so these particular bivalves are actually cold sea. Okay. And mollusks from cephalopods. Also, this is the Nautilus from Batangas. More cephalopods. This one is not our study. This is from Sato and others. From Mansalay, Mindoro, I felt like I should put it because it's one of the older fossils that we have in the Philippines. Echinoderms, sea urchins from Matabungkay. Fossil fishes, which Merrick showed earlier from the Laguna Formation. Of course, in the museum, we have a lot of the vertebrates that we collected from Antipolo some time back. Also, there are more petrified wood samples and more leaf samples also in the museum. And also, I'd like to show you ichnos fossils, or the fossil burrows trails, which depict behavior of these organisms. And they depict certain environments. So these are from the shallow water environment. In Leyte, this is also shallow water environment, thalassinoides. So these are tracks. Rhizocorallium, also shallow water. Deep water environment, ichthyofossil. These are burrows or traces of maybe gastropods or echinoids that went through them from Palawan. And lately, we've also done studies on index fossils of the Philippines. And I'd like to just to advertise that in the website of NanoWorks, we've actually put in maps where we summarized the occurrences of fossils in certain time periods, or index fossils in certain time periods of Philippine history. And so in general, there are fossils around us. If you're interested, please visit the museum when we're allowed. Also, we'd like you to be part of the Paleontological Society of the Philippines. And if you want to check out more about fossils, you can look at the NanoWorks website and also get in touch with us. Thank you to all of these people who helped put together a lot of the material here. Actually, the material is from them. And thank you very much for listening.
All right. Thank you very much, Dr. Alampay, for that talk. Okay. So, of course, thank you also to Mr. Mary for this talk a while ago. Now we are opening the floor for the open forum. I see that we have some comments and questions already in the chat box. So, if you have more, just type it in, including your name and your affiliation, and we'll be presenting it here, and we'll see what our speakers can say about it. Okay, so for our first question, this is from Mr. Denver Soyom from University of San Carlos of Cebu. Hi, I'm currently taking an MS in biology, also applied for applied paleontology online course. Here, his question is, what can you suggest for a Filipino who would like to become a paleontologist, especially as geology degree seems to be quite rare here in the Philippines? And yes, are there any projects that we can attend to, such as fossils collecting and studying in the Philippines? Like for my case here in Cebu. So maybe this is for Mr. Tabiso, but if Dr. Alampay could also chime in, please feel free to. Sir Mary?
I think Dr. Lisa can share more about this since I'm still just starting phase of my um, study. So, ma'am, if you can.
Okay. Actually, really, to be a paleontologist, you either have to be a geologist or a biologist. No, because you really need the fundamentals in order to be able to identify them and at the same time put them in their context. No, so because it's quite important. You know, it's not just a matter of collecting them and putting them in a box. You really have to be able to put meaning in them, you know, put some sense into them. So it's actually essential that you go through either geology or biology. Having said that, in the Philippines the best route is actually geology, because it's the geologists who become paleontologists who really are into collecting and studying them. There are many geology programs now in the Philippines, but they're not as big as the ones at NIGS in UP Diliman. There's one in Adamson, in Mapua, in Bicol. There's Partido State University. There's also one in Visayas, in Negros, Norsu, and also in Davao. No, there are geology programs in the Philippines in our public university or state university. So you can start off there. But really, you know, here in the Philippines, paleontologists are actually in the geology realm. Although you know that's not true all over the world, we have a lot of colleagues who are biologists,
Mhm.
but many of them also are actually geologists.
Okay. So I hope that answers the concern.
I,
But I think yes, I think that's
I
good
just want
answer.
to add, since Denver is from Cebu, so
Mm-hmm.
actually there's a lot of fossil in Cebu. So my if you in the first part of my introduction, so our field for the field geology course are actually the area is actually in Cebu. So we're able to collect a lot of mollusk fossils, for example, in Naga. So personally, I'm very interested in exploring the terrestrial deposits from the Oligocene, Lake Oligocene, so the Cebu Formation. So possibly there might be vertebrate fossils there. So I'm very keen to explore those, but currently it's very hard to do
Mm-hmm.
field work and collecting. So yeah, we can probably collaborate sometime in the future, but
Hopefully.
not really in the near future. But yeah, maraming fossils sa Cebu.
But yeah, hopefully din sa future, magkaroon ng more ng study in fossil collection, especially in Cebu, especially for Mr. Denver. He's really interested to be part of it in the future. Okay, for our next question, this came from Sir Raymond Tadeus Ancog from the Mines and Geosciences Bureau. Uh, he said that it would be interesting if marsupial fossils will be discovered in Davao Occidental because it would imply a northward migration of Australian fauna via Sulawesi. We already have Australian flora in southern Philippines or the Eucalyptus deglupta, but flora dispersion is easier, of course. Do you have any comments on this from Mr. Ancom?
Ah, ah.
Maybe, maybe
Sige.
Kakao.
So I'm actually also interested in that because I mean in the general sense, kasi if in out offshoot of my Joel 170 as well, in field geology that I mentioned, one model, paleogeographic model from Zahirovic, I forgot to date, is that they modeled the central Visayan areas, the island arcs to have been like formed like offshore New Guinea. So it probably the islands that make up the now Central Visayas might have developed in that area. So possibly there might be some remnant mga organisms that have migrated from the Australian or at least the New Guinea islands, and then migrated into the that part of the Philippines and later on spread. So one aside from obviously we have a very lacking na fossils because maganda siya i-test if we're going to look at those that cannot really easily like uh, migrate to using the seaward route. So those that are restricted by like freshwater or generally terrestrial organisms. So if we can find these organisms in the fossil record probably that can be used as an evidence. Also, the phylogenetic, mostly yung mga molecular phylogenies. So using yung mga phylogenetic tree kung kailan nag-split and then looking into their yung mga sister taxa. So I've seen some that are actually being related to New Guinea. So that there might be some evidence there, pero yan, very interesting nga po yung if we're able to find fossils from probably older strata, particularly those that cannot really travel through like seas, like swim and so on.
Anything to add, Dr. Elisa?
Um, Sir Angkog is actually a colleague. He's a paleontologist as well. No? So actually, one of the areas here was also part of his thesis, just like it was mine. No? So actually, it would be quite interesting. No? We really need more hands. We're getting older already. We used to be the young ones, but we're getting older, and we need more people who would like to get into paleontology. One of my Dr. Matias, who is our predecessor, always told me that if you want to be famous, it's paleontology is the way to go, no? Because everybody's interested in fossils. Nobody's interested in the igneous rocks that you discovered. It's really, among the geologists, what is the most fascinating for many people, the public, from kids to the seniors, are really fossils, no? So if only we can have more hands. All of us are, especially when you're faculty in UP, you have to do the triumvirate of functions from teaching, research, and committee work or extension work. And some of us are even administrators. So we
Mm-hmm.
don't have that much time anymore. And really, paleontology needs expertise. So the expertise is very specific. Some of us only study, large foraminifera. Some of us only study coccolithophores from a particular period in time. And so it's a very specialized kind of work that people do for their entire lives. Yeah. For example, I myself, I'm a calcareous nanofossil person, but I have to do other things also, like the vertebrates and invertebrates. But really, I'm an expert mostly in calcareous nanofossils. And it's a lifetime. It's decades of work from grad school onwards. And then we try to mentor more people, but then, we lose them sometimes to mining companies because they earn more there. But paleontologists who are in state universities and public institutions now earn a decent living because of the tranches in our salary grade. So it's actually worthwhile to stay in universities and to study these things. But we need more people. So in order to be able to study those things, we're hoping that Merrick will continue on and will not be discouraged. We've been trying to get a person to study vertebrate fossils for the longest time. It was my passion also as an RA when I was young because of the surprise discovery of the stegodon fossils in Antipolo, but I could not pursue it. I had to go back to my roots in microfossils because that is what is needed in geology. So at the time, but sana nga.
Hopefully, maybe the administration, whether in the different universities or maybe in the Philippines government, could do something about it, especially maintaining those who could stay in the research field and the public sector rather than going to private mining companies.
And the
Um,
basic research is very important actually. There has been a lot of development now because of the National Museum also. So
that's
natutuwa kami that some of our grad students actually ended up in the National Museum and building the staff there and hopefully staying, contributing there as paleontologists for the rest of their lives. No? So meron namang nangyayari.
That's great. That's a small start for us. A little follow-up question from Sir Raymond as well. Maybe the two of you could input some answers here. How can we collaborate to explore sites being developed without hampering their construction timelines? I want to come up with an agreement with construction companies such as the MRTs, LRTs, and the Metro Subway as well also for condo towers, where paleontologists can extract and study fossils discovered during excavation. I believe such agreements are in effect in other countries. The main concern I foresee is how not to disrupt the schedule of excavation. So, do you have any uh, comments on this question?
Um, uh, Siguro mahirap talaga. Actually, some of the fossil finds that we have in the museum were contributed by engineers or alumni or geologists who see, fossil tree trunks, yung mga petrified wood or leaves and so on na nasa mga na nakikita nila sa mga sites like for example sa Ortigas ganyan. Pero mabilis kasi yung mga timelines nila and it's actually quite dangerous sometimes. But in UP campus, in my younger days, nung naglalagay ng mga pipes, bumababa ako dun sa mga hinuhukay and naghahanap nga ako, hoping ako na merong fossil elephant ako makita doon in the same way that I found it in Antipolo. Pero hindi ako naging successful. Pero si Alan Fernando, nung nagbubungkal sa may gym, actually in the area, sa UP Diliman, ang daming binungkal in the past 2 years. Ang dami kasi nating construction projects. May mga lumabas. One of the pictures there, may mga lumabas na mga petrified wood na nandoon. But we've always had also a lot of leaves, no, and so on. Pero yun nga, ang hirap talaga nung makipag-coordinate kasi may mga schedule ang mga yan. Unless siguro nakalagay sa batas o regulasyon ng mga LGUs nakalagay yon, mahihirapan tayo talagang pumasok doon. Pero may mga mababait naman. Kaya lang you have to get within the schedule nila, no? So yun lang yung nagiging problema talaga. Pero dapat nalalaman mo kaagad na merong ginagawang construction para ka makasingit. Pero hindi siya priority of course, no? At hindi naman ititigil ang mga multibillion projects para makakuha ka ng fossil, no? Pero in other countries it's also a challenge, no? Challenge sa kanila pero yun nga dapat may funder ka eh. The only way you can keep a place kunyari na hindi nila galawin, bilhin mo yung lupa pero bibilin ng state kunyari yung lupa at gagawin siyang reserve para hindi siya galawin. Pero marami sa mga fossil areas na mga pinuntahan namin sa Antipolo kunyari punong-puno na ng bahay ngayon, no. In the past we were dreaming baka pwedeng bilhin ng university o kaya ng gobyerno pero that would take some time ginagawa na yung subdivision. So mahirap yung agawin. Meron ng mga may-ari nung binubungkal mo at inubos na nila yung bundok. So wala na yung mga sites na yun.
Medyo mahirap nga din po ito. Kasi mukhang ang step talaga for paleontology to put forward sa ganitong klase ng project is mauna ka.
Oo.
Pero,
makakita ka. Oo.
Pero it would be hard yun. It would take some agreement din. And agreement itself would take time. Especially here in the Philippines. So it's a challenge talaga po. Right. So we have another question from Mr. Sai. I'm not sure if it's Mr. or Miss. I think Mr. Cyrus Gerard Fernandez. Can paleontology be a tool in gathering facts to resolve issues on the West Philippine Sea? So medyo timely ata itong tanong niya.
If Merrick will permit me, ako na naman magsasagot. Actually, it has been used. The sciences have been used in order to stake our claim. For example, in the Spratlys way back in 2011, basta ganyan, there was a cruise there. It actually was a Vietnamese-Philippine cruise in the Spratlys. And the reason why that was put together was that to show that we are actually studying those islands and that we're staking our claim on those islands, no. However, those islands that were visited where the expedition happened, they were, of course, you see them in the news. They were paved over. Those reefs were paved over, and we lose a lot of that natural habitat. Yes, it can be used. That's the reason why we were able to go on these expeditions in the South China Seas, because every time there's one, the scientists from the nations who have a claim in at the particular area where the drilling is going to happen is actually invited. And so that's the reason why we can get on these expeditions and later on be able to collaborate with those scientists, no, down the line. Pero oo, pwede siya talagang gamitin. It's an indirect way of staking your claim on islands because it means that you're studying them. However, of course, having said that, the Chinese have studied it a lot also without our knowing. We would see publications cropping up everywhere of geological studies being done in areas which are in Philippine territory without the knowledge of Philippine scientists.
So, medyo ano din po, no? But
Right.
yeah, that's great. Maybe that could be something na pwede pang i-work on sa atin to get to take back our rightful claim for the
Uh,
West Philippines.
the Marine Science Institute is also very much in the forefront of this. No? So all of us know that there is a reason behind it, but we're scientists, so we try not to be in the politics of things. But
Yeah.
for us, we just want to be, because it's unknown territory,
Yeah.
and it's samples that we can get, that we cannot usually get with our resources here in the Philippines. So we grab those opportunities, and it also is very helpful for us in our graduate programs because the material can also be studied by our graduate students. Mahirap kasing kumuha ng samples, especially if in the middle of the ocean. You need these big ships na
Mm.
kinukwento ko kanina. Meron na rin tayo ngayon. Pero in the decades past, wala. So talagang ang hirap din.
Okay. Anything to add, Sir Mary?
No. Okay na yun.
Bata pa si Merrick. Bata pa si Merrick nang nangyayari natin.
Sabagay. Yeah. Okay. Another question from Mr. Robert Kobe Mendoza. He's from Mapua University studying geological science and engineering. I would just like to ask a bit of an advice. Since our field is somehow will go through engineering or they'll be focusing on engineering, how can we pursue being a paleontologist while being a geological engineer? So, any of you?
Si Merrick may mga kilala naman. So,
Ah, geologist pa rin naman sila. So if you're still have background in geology, you just need to like focus more. So for example, you're going to specialize in paleontology in your MS, for example. So
pwedeng thesis mo. There have been some undergrad students from Mapua and Adamson, for example, and even Norsu and the other universities who come over to NIGS to do their thesis with us. So, ang degree kasi sa kanila, ang pangalan geological engineering. Mas may konti silang engineering, but actually pag kinumpara mo, it's actually BS Geology siya ng NIGS, ng UP din. It's the same. So, hindi siya masyadong nag-iiba. It's the same. So, sa undergrad, it's generalist naman lahat sa undergrad eh. So, pagkatapos nun, pag thesis mo, undergrad thesis mo, kung interesado ka talaga sa paleontology, we suggest na you go, meron din kayong mga paleontology teachers, yung mga nagtuturo sa inyo ng sedimentary petrology, at saka ng paleontology, at saka geologic history, ay mga paleontologists din sila. So, they can actually be your advisors for your thesis.
Ayan. So, Sir Mendoza, if ito talaga yung gusto nyo, tara na sa UP. Char. And, another question, same from Mr. Denver Suyom. Are there many who study the fossil collections in the Philippines? Do you think we can still get more information from the fossil collections that we currently have, example in the Philippine Museum, despite being fragmentary and isolated? I am most interested in systematics na biogeography and have really been thinking for future research with regards to the collection.
um,
Sir Mary?
so yes, actually we can still extract a lot more from those that are stored in museums. So personally, me with my advisor, Dr. Alan Fernando, we're actually requesting for national access with the National Museum specimens. So personally, I want to look more into the systematics as well of the proboscideans. So probably I can sort of have some ideas or elucidate how they migrated and probably if there were actually evolution, or I mean, they evolved into different species when they migrated towards the Philippines. Because again, based on the literature, we actually have lots of different proboscidean taxa that were described, although most are actually not really their taxonomic positions are not well defined. So we can probably look more and personally, I apply phylogenetic studies on the mostly molar fragments of proboscideans, the stegodons, and the elephant. So yes, but one main concern personally for me is that most are actually not their stratigraphic positions are not well established. So probably we still need additional specimens because relatively the vertebrate fossils are very lacking. But if we're going to go at other museums abroad that have these very wide collections, So most are actually now focusing on their specimens that are already in collection. So for example, in the one that one professor that I'm talking with in UMich in Michigan, so they're actually the proposal is actually just going to focus on the fossils that are already in the museum, because lots are actually just cataloged, and we can still extract a lot more information from them, aside from their identification. So marami pa tayo pwedeng makuha, their paleoecology, the dynamics of evolution, and so on, just by those that were already collected probably decades or hundreds of years ago. So ayan. But again, for the Philippines, we still need to collect more. And generally, a suggestion na lang, if you have ever, parang may narinig ko yung finds ng vertebrate fossils, probably best siguro is to take note of the area where that fossil is, because we need to get the context kung ano yung stratigraphy, yung layer nun, kung saan nakuha, to generally have this yung stratigraphic data na nga. So parang kunyari, if you want to compare yung assemblages tapos yung paleoecology nila, so we need to first know that they existed together or in the same time range. Kasi kung may niche partitioning mo, for example, pero kung if they are collected from the surface, or yung nag-collect is parang collector and then was extracted from the layers na. So wala na tayong context ng fossil na yun. So again, very important pa rin yung context aside from the fossil itself. So yes, to answer your question, marami pa from just fossil collections, you can still extract a lot more information.
Madami, parang simula pa lang din talaga po yung paleontology here in the Philippines, and there are many much more to discover. Yeah.
Actually, we have to qualify, no? Yun yung sa malalaking fossils. Pero sa microfossils, matagal na yung history. Naka-isang century na yata. Kasi Challenger expedition pa lang, meron na. Dumaan yun dito sa Pilipinas. So may mga naaral, yung mga foraminifera na kinukwento ko kanina, mahaba ng pag-aaral dito sa Pilipinas, at established ang zonations noon. So talagang very good age determinant sila. So in the sense of it being fragmentary and discontinuous siya, medyo mas marami tayong data. No? Hindi siya ganun ka-fragmentary at discontinuous. Ang hirap tayo talaga is in the larger fossils, the invertebrates and the vertebrates. And even yung mga plants, hindi tayo masyadong magaling doon. Tsaka hindi din naman kasi, mahirap din talaga ang plants aralin kasi hindi nakokompleto yung katawan. So ang hirap niyang i-identify. Pero when it comes to microfossils, especially foraminifera at saka calcareous nanofossils, medyo maayos ang ating, kasi kinailangan naming aralin maraming mga areas. So land sections and deep sea sections, marami na rin tayong naaral. So hindi siya ganun kasi nandun nga naging tradisyon nung paleontologists sa Pilipinas, nasa micropaleontology, because of oil and gas exploration and coal to some extent also. So marami, at saka sa konting sample, marami ka nang nakukuhang specimen. So libo-libo, as far as the eye can see, kumbaga, libo-libo na nakukuha mo sa kakapiranggot lang na sample. Yung calcareous nanofossils, dulo lang ng toothpick kailangan namin sediments, na bibigay na namin yung age date sa'yo in 15 minutes. No? So, pero pagka vertebrates ang pinag-usapan, fist size lang, swerte ka kung molar yon ang makuha mo, or part ng skull. Pero kung kunyari mga legs lang yung nakuha mo, hindi mo talaga, ang hirap mag-identify ng mga ganon. So by nature, ang invertebrates, especially ang vertebrates, fragmentary talaga ang record. And that is part of the science. You accept that part of the science, that there's a lot lost in nature, no? Not many are well preserved. So kaya sineselebrate natin, maski na yung mga nakikita nating mga hominid na fossils, mga ngipin lang o kaya parte ng skull na basag-basag, nako, sineselebrate yon at ang lalaking mga papers sa Nature and Science kasi nga hindi ka talaga halos nakakakita. So yung mga elephant fossils, it's the same. So yun siguro, just to qualify. So kung gusto mo hindi ka masyadong problematic about the number of specimens na per sample, pumunta ka sa micropaleontology. Pero kung gusto mo yung big things, actually interesting sila talaga. At saka may invertebrates, cutie kasi sila. Go ka sa invertebrate and vertebrate paleo. We need more people there, but we need people to be dedicated all their lives and to mentor more students afterwards also, because that's the way that science works. No? We mentor others, you pass on the expertise to graduate students. not undergrads. No, undergrads will come and go. But it's the graduate students that you really need in order for the science to flourish.
Thank you very much. Okay, I think we still have room for two more. So if you have more, just keep coming. But we'll just read two more questions and then we can proceed. Okay, so we have the second to the last question came from Mr. Jericho from UP BRSL. For Sir Merrick, sa mga fossils po na nakita sa bansa natin, meron po bang part ng burial ceremony or near human remains din po? Tsaka ano po kaya yung possible reasons bakit po wala na sila ngayon sa bansa po natin?
Ayun, actually marami yung associated with archaeological finds. So most ng mga very young, yung mga vertebrate fossils were being associated with hominins, yung semi-complete na fossil ng Rhinoceros philippinensis were actually butchered. So parang kinatay. And other were typically relate, parang nakikita nila sa mga caves and stuff. So yeah, I'm not sure kung sa burial per se, kasi hindi ako masyadong nag-delve on yung mga archaeological finds. Pero marami actually associated with those. Tapos, yan din. There are actually mga hypotheses regarding why and when they went extinct, these megafauna. So, isang main hypothesis is yung arrival ng mga hominins. So, possibly later on, since very prolific yung studies natin sa archaeology, maraming mga recent archaeological finds. So, we can probably get some more updates regarding that very soon. So, although syempre kailangan natin ng more collection din ng vertebrate fossils to matime natin kung kailan sila went extinct and kung same ba yung timing nila, for example, sa arrival ng hominins. Actually, that's being tested all throughout kasi mayroong megafaunal extinction, yung Pleistocene megafaunal extinction, yung sa mga sa steps, sa mga yung mga mammoths, for example. So, may mga hypotheses na hindi medyo like final blow yung arrival ng hominins, but the changing the climate is already like devastating the populations ng mga megafauna na yon. But again, obviously we can still contribute here in the Philippines regarding that, since medyo nasa equatorial side tayo, but baka yung climate might not really be that much of a factor, for example, compared dun sa mga northern latitudes. So yeah, sa archaeology and well, parang work na ng archaeology and paleontology dyan.
Okay. Thank you. And I hope that answers that, Jericho. Last question before we proceed. From Miss Eleanor Basilio. Knowing the significance of the field, are there efforts being made to promote or somehow integrate some basic concepts in paleontology in our basic education?
Meron namang efforts. Many of us as geologists have been part of yung sa K-12 program, for example, ng CHED. And the curricula actually, yung may earth science curricula, may earth science subject na rin kasi sila. Pero yung isang earth science subject, it's together with biology, di ba? Parang minix yung dalawa. Actually, when you study the history of the earth, kasama doon ang fossils or the study of paleontology. So, all of the concepts that you need in order to understand fossils are actually geological concepts. No? Yun nga lang, very specific na kung gusto mo mag-identify ng mga specimens. No? Pero paleontology is actually, yung mga kailangan mong concepts is actually geology or earth science. Kaya madalas nagtatawag, there's always a campaign from us. I always, especially nangyari yung K-12, kailangan talaga ng mga geology graduates na magturo sa high schools natin, especially sa grades 11 and 12. Kasi quite specialized na talaga yung curriculum. Hirap kami kasi hindi din kami ganun kadami. Hindi kasing dami kunyari ng mga inhinyero o kaya kasing dami ng chemists o biologists sa buong Pilipinas. Ang geology kasi has not been popular kasi nga, well, as Filipinos, I guess, Nung unang panahon, kunyari kami, konti lang ang mga babae sa geology program. Minsan 3 lang kami or 5 or mag-isa ka sa klase ng 40 or so na mga lalaki. Pero that has changed, no? Our classes now are quite large. Sa 70 na students, kalahati nun or more than kalahati mga babae na ang mga nandun. There's more acceptance also for women to be in mines because we were told before we cannot work in mining jobs or go underground kasi malas daw ang mga babae, pero nag-change na rin yun ngayon kasi nga yung supply ng geologists kumonti na yung mga lalaki. So yun, it's really konti lang kasi kami. At the same time, geology is a little bit specialized. It's an applied, very applied science. It's an interdisciplinary, within the basic sciences, interdisciplinary siya. Tapos ang topic mo ay Earth. Tapos may malaking kailangan na pag-intindi ng malakihan, kahapon lang kinukwento ko to, malakihang mga prosesong nangyayari. Plate tectonics, yun. Kailangan na intindihan mo yon na tinatanggap mo at nakakakita ka na ng evidence na talagang gumagalaw ang mga plates ng mundo, yung mga nasa ilalim ng dagat at yung nasa land. Tapos climate change is also a geological phenomenon, no? Na inaaral din niya ng mga paleontologists at saka ng mga geologists in general, kasi nga ang evidence ay nasa bato. So kung gusto niyong makwentuhan ng kung anong nangyari ng climate change in the past, you talk to a paleontologist, geologist, historical geology person kasi yun ang mas nakakaintindi at mas naisabuhay yung mga konsepto at yung mga pangyayari, no, in the past. Kasi yun talaga ang tinitingnan namin. Pero oo, merong effort naman po, pero kailangan kasi ng medyo specialized na expertise na pumasok. A geology graduate at least, or geological engineering, or kung anong tatawagin nila dun sa geology degree. Pero meron naman po tayo niyan sa bansa. Kaya kung nasa high schools kayo or yung mga universities nyo, may mga high schools, hire a geologist to teach the earth science subject. Kasi yun, merong kakaibang pananaw na maibibigay doon sa klase at mas interesting, magiging mas interesting yung subject.
Sabi nga po ni Sir Antonio de Guzman, in senior high school, earth science is being taught but it's not properly teach because most teachers in senior high school major in biological science, physics, and chemistry. So yung same sentiments po sa inyo.
Totoo. Kaya nalulungkot kami kasi minsan di pa nakakita ng bato yung mga yon. I mean, nakakita ng bato sa pang-araw-araw pero hindi nila naiintindihan yung kabuluhan ng bato. Kasi pag tinatanong mo kami, ano ba inaaral? Yung talaga bato lang inaaral namin. Parang anong bato? Oh, bato around you. So ang hirap i-explain nun kasi parang yung mga sumasama sa ano, tinitingnan yung mga bato, ang kinitingnan nyo. Yung mga bato, marami yung kinakwento sa amin. So, but it takes years of training. You have to go through a bachelor's at least, and then be really interested in looking at it. And of course, reading up. No, kailangan nagbabasa din at pinapalawig ang ating kaisipan. Very important yan.
Okay, thank you. So we really have a challenge in this field of paleontology, and we are really grateful na kayo, Mr. Merrick and Doc Alampay, ay nagbigay ng knowledge sa amin today. And so I guess we still have more comments and questions in the chat box, but just keep it coming. We'll just collate it and send the copy sa ating speakers today, and hopefully makapagbigay kami ng sagot sa inyo as soon as possible. And so again, thank you very much, Dr. Alampay and Sir Merrick. But before we award the certificates to you, to our audience, if you like our webinar and discussions such as this one, don't forget to like and follow us in our socials. You can find us in Facebook or in YouTube, both BRSL and NSRI. We also share updates in our services as well as the news and innovations in the field of biological science. Okay. So of course, again, biggest thanks to our speakers, Dr. Alampay and Sir Merrick, for sharing your knowledge. And to show our appreciation, here we present these certificates of appreciation to you. Slides. Ayan. So, the Biological Research and Services Laboratory gives this certificate of appreciation to Mr. Merrick Tablizo for having delivered a lecture on vertebrate paleontology in the Philippines, current status and future prospects during the BRSL webinar series 7th episode with the theme PaleoConnect, the past is the window to the present and future, held on the 27th day of April 2021 via Zoom signed by Dr. Pierangeli G. Vital and Dr. Elmer S. Estacio. Claps. um, Also, we give this certificate of appreciation to Dr. Alisa M. Pileo Alambay for having delivered a lecture on fossils in the Philippines, understanding the past and the present during the BRSL webinar series 7th episode with the theme PaleoConnect, the past is the window to the present and the future, held on the 27th day of April 2021 via Zoom, also signed by Dr. Pierangeli Vital and Dr. Elmer S. Estacio. So thank you very much to our speakers. Of course, we cannot end this webinar without hearing a few words from the head of our laboratory. May I call on Dr. Pierangeli G. Vital for our closing remarks. Doc Pai?
Thanks, Nikki. Good morning, everyone, to both participants from our Zoom room and also those watching us in our YouTube. So for this webinar, please allow me to thank the following. First, of course, our speakers, Sir Mary Q. Tabliso and UP AVP Dr. Alisa Peleo Alampay. Thank you very much po for graciously accepting our invitation amidst your busy schedule and for sharing your expertise with us regarding geology or paleontology in the Philippines. I personally learned a lot, in particular that a million year is considered short in geology. And I'm sure po that the students in the audience are inspired to walk in the same field. So another virtual round of applause, please, for our great speakers. Nasa reaction button po. Thank you. Second, this webinar will not be possible without the support of our NSRI Director, Dr. Elmer Stasio. Salamat, Sir Tux, for being with us from planning the webinar to webinar proper up to the post-webinar concerns, and the efforts, of course, of the remarkable researchers and staff of BRSL. So BRSL, guys, if you are capable of turning on your videos, please do so to show everyone our yellow UP BRSL Zoom background that you see now. If it's not too much to ask to everyone, please click the memoji or reaction button to show our appreciation. So thank you, guys. Earlier, we already saw the available resources and services at our lab, Biological Research and Services Laboratory, in Natural Sciences Research Institute, UP Diliman offer. Although our lab is still physically closed, we are accepting online consultations and continue to organize webinars such as these. So please feel free to email or contact us if you have biological concerns. Also, stay tuned with our BRSL Facebook page for updates. Third and last, I would like to thank all of you, our participants, coming from all parts of the country and even the world. Whatever your time zone is, either waking up very early or staying with us late at night to join us, who show great interest and enthusiasm in biology and of course its allied fields such as geology, and joined us this morning, again might be night for you, for the BRSL webinar episode 7, PaleoConnect, the past is the window to the present and the future. With this, I wish you to have a wonderful and safe day or night and week ahead, and I hope to see all of you again in our future activities. Thank you very much, and back to you, Vicky.
Thank you very much, Doc Pai. Okay, so as we now approach the end of our webinar episode, again, we would like to thank everyone, our audience, and of course, our speakers for taking the time to join us today. May we request everyone to open their cameras and join the photo documentation. Yeah. Nice, Scott. That whenever you're ready.
Okay, meron po tayong 5 pages.